Alright, welcome back to Geometry. Here we go, Chapter 10, Section 2. We're talking about arc measures. Alright, in a circle, you have a minor arc and a major arc if you have a central angle. The minor arc, well, is the smaller one, right? So that's less than 180. And the major arc is the bigger one. So if you have an arc of 180, then we would call that a semicircle. A semicircle is an arc with endpoints at the end of the diameter. Now the central angle, and you'll see that term right here, is the vertex, is where the vertex is at the center of the circle. So here we have a central angle, okay, for this arc. Now the measure of the arc, a measure of an arc is the measure of its central angle. Let's say that this is 50 degrees, then the measure of arc AB is 50 degrees. Oh, sorry, arc AB is 50 degrees. The measure of arc ADB is 360 minus 50. So the major arc would be described with an extra point. That way they tell you, okay, I've got to first go from A to D to B. If they just say AB, we're going the shorter way. And so the measure of arc ADB, oh, not line, here we go, arc ADB would be 310 degrees. Alright, find the measure of each arc. Here we've got arc RS. The measure of arc RS is 110 degrees. That wasn't very difficult. Measure of arc RTS is from here, we're going around. Now we've got the major arc, so RTS, so that's 360 minus 110, and that is 250 degrees. And then the measure of arc RST, so we're going from R this way over TS to T, and since this is a line right here, that's the diameter, that is a semicircle, that's 180 degrees. Okay, the arc addition postulate says if you have two adjacent arcs, then the arc from one point to the other is the addition of both. So ABC is arc AB plus BC. Pretty easy stuff right here. Find the measure of each arc. So the measure of GE, we have from G to H to E. So that's arc GH plus arc GE, and that is 40 degrees plus 80 degrees, and that is 120 degrees GEF. So we're going from G to E to F. So we keep going right here. So that's this one. That's GE plus EF, so that's 120 plus 110, and that is 230 degrees. And then GF, that is going to be going the other way. That's this way. So that is 360 minus the 230, and that is 130 degrees. Boom. It's that easy, ladies and gentlemen. Congruent circles theorem. Okay, circle A is congruent to circle B if and only if AC, and that's the radius, is congruent to BD. So if they have the same radii. Two arcs are congruent arcs if and only if they have the same measure and, very important, they are the arcs of the same circle or a congruent circle. So if you have a smaller or bigger circle, then the arc's going to be different, right? And then they're similar if they have the same measure. Alright, congruent central angles theorem. We have in the same circle or in congruent circles. Two minor arcs are congruent if their corresponding central angles are congruent. So if you have 45 degrees and 45 degrees, then those are congruent. All right. Tell whether the arcs are congruent. Explain why or why not. All right. Here we have one circle and the same measure. Yes. And y is same measure. Measure. Same circle. Remember, just being the same measure is not enough reason. All right, because here these two have the same measure, they're 90 degrees, but the answer is no. Why? Because different circles. Different size. I'll specify that it's a different size because these two are also different circles, but they are still congruent. Different size circles. That's pretty sloppy there. Circles. Okay, and then here the answer is yes, because same measure, and since we know that this radius and this radius are congruent, we know that these two circles are congruent. So congruent circles. So you need two reasons to justify. Similar circles theorem. This is probably my favorite. All circles are similar. Like this one and this one. They're similar. And that one's similar. This one's also similar, and that one. This one's also similar to this one, and that one's also similar to all the others. As is this one and that one. Those are similar. As is that one and this one. And that one. Ladies and gentlemen, they are all similar. Good times in the Matherhood. Check in again next time for another fun lesson.